Okay, college algebra, let's talk 4.3, logarithmic functions. So a logarithmic expression is for all real numbers y and positive numbers a and x, where a is not equal to 1. Y equals log base a of x is the same as x is a to the yth power. This is an equivalent form of an exponential function. What it does is it isolates the exponent, so it gets the exponent by itself. This is helpful for equations when your variable is in the exponent and you want that variable by itself. The first thing we're going to do is practice rewriting. Okay, so the base of our exponential becomes the base of the logarithm. The base of the logarithm is the little subscript number in the logarithm. The thing that it's equal to is the inside of the logarithm, and again, the logarithm isolates the exponent, so the exponent becomes by itself. So 2 to the third equals 8. That's the same statement as log base 2 of 8 equals 3. So we're both saying the same thing. Let's try again. X is our base, so x becomes our base. Log base x, 9 inside the logarithm, and 1/2 is the exponent, so it gets isolated. Lastly, 5 to the x equals 1/25. Log base 5, the base again becomes the base of 1/25 equals x. These should be free and easy questions. Now, if we can go from exponential to log form, we are expected to go also from log form to exponential form. So just like it's going backwards. So the base of our logarithm becomes the base of the exponential. Remember, logs isolate the exponent, so if it's by itself in a logarithm, it becomes the exponent equals 81. So 3 to the 4th equals 81. Let's try again. Base to base, isolated becomes the exponent, x to the 5th equals 32. And lastly, log base 1/2 of x equals -4 changes to 1/2 to the -4th equals x. So again, easy points. Rewriting shouldn't be that difficult. Now, even better, if you have log equations, you just convert them into exponential equations and solve them like you did in 4.2. So there's nothing new here except you have to convert it first. So instead of log base 8 of x equals 3, we rewrite this to 8 cubed equals x. And 8 cubed, 8, 64, 512. We just say x is 512. So that one was super easy. It may not always be that easy. Log base x of 8/27 equals -3. We rewrite it, x to the -3rd plus 8/27. Now, if we don't like negative powers, I'm going to show you a trick. To get rid of the negative power, we can flip the side opposite our variables. So that means x to the 3rd instead of 8/27 is 27/8. Because normally we would flip it on this side, but because of cross multiplication, it ends up just flipping the other side if you're trying to get the x by itself. And then to get rid of a cubed, we take the cubed root. To take the cube root of a fraction, you just take the cube root of the numerator and the denominator. So the cube root of 27 is 3. The cube root of 8 is 2. Lastly, log base 49 of the cube root of 7 is x. Rewrite 49 to the x power equals the cube root of 7. Remember that a root can be written as a fractional exponent. 49 to the x equals 7 to the 1/3 power. Now, this is one of those exponents from last time. My x is in the exponent, so I need the same base. So I really need 49 to be 7 squared to the x. That means I have the same base and they're equal, so the exponents are equal to each other. So that means 2x equals 1/3. And if you divide by 2, you get x is 1/6. So today will probably be 3 videos. All of your tests should be graded and in there. I think this weekend, or maybe once 5 or 4.2 and 4.3 are in the grade book, I will remove your lowest 5 homework grades and put an updated homework average in MyLabs Plus going into next week so you have an idea of where you sit. And we'll do more next.